In this video, we will solve a JEE Mains previous year question based on the binomial theorem. Let us carefully understand the problem and learn how to approach this type of question. This question was asked in January 2026 session. Let us carefully observe the problem. In a problem given that s is equal to some expression in factorial up to 13 terms, and also given that 13s is equal to 2 power k over n factorial, then ask the find the value of n plus k. Now s is equal to given that 1 over 25 factorial plus 3 factorial 23 factorial plus 5 factorial 21 factorial up to 13 terms. So this type of question, we are just write the general term of this expression s and also find the 13 term also. How to find the 13 term? If you observe the question, if you see the pattern, it is 1 factorial here, 1 factorial, then 3 factorial, then 5 factorial up to 13 terms. So how to find this 13 term? If we see 1, then 3, then 5 up to 13 terms. So it is an AP series. AP series, how to find the AP series term? Tn, suppose Tn is the nth term. AP series, A is the first term, n minus 1 into D. D is a common difference. Therefore A is 1 and T13 we need. So 13 minus 1, D is increased by 2, 1, then 3, then 5. So it is 2. So therefore 1 plus 12 into 2, it is 24 plus 1, 25. Therefore up to 25 factorial into 1 factorial, and because 1 factorial is 25, 23, 21, it is decreased by 2, it is increased by 2. So it is up to 13 terms. That means it is going 25 factorial 1 to 135 up to 25, and 25 is decreased to 1 factorial. So our s actually 1 factorial, 25 factorial, 3 factorial, 23 factorial up to 1 over 25 factorial into 1 factorial. Therefore we got s is equal to 1 over 1 factorial, 25 factorial, 3 factorial, 23 factorial, 1 over 5 factorial, 21 factorial up to 25 factorial into 1 factorial. Now we want to write the general term of this sum. Let TR is the general term. So in general term, above part is 1 and it is going 1, 2, 3, 1, 3, 5 up to 25. So it is odd term 1, 3. How to write the odd term? 2r minus 1 and is factorial, so it is factorial as it is, and 25, 23, 21. So it is 25, 23 up to 1 factorial. It is going back to 1. So how to write this term? It is odd term, but it is decreased by minus 2. So how to write? If you write 25, how to write 27 minus 2? In this way, so it is right 27 minus 2r factorial. Therefore, we got the general term is 1 over 2r minus 1 factorial, 27 minus 2r factorial. So we need to show 25, 23, 21 factorial. If we put r is equal to 1, then 27 minus 2 is 25 factorial. R is equal to 2, 27 minus 4. 27 minus 4, it is equal to 23 factorial. It is okay. And similarly, r is equal to 3, it is 21 factorial, and so on. R is equal to 13, it will be 1 factorial. So we got TR is equal to 1 over 2r minus 1 factorial, 27 minus 2r factorial. Therefore S is equal to summation over R is equal to 1 to 13 over 2r minus 1 factorial 27 minus 2r factorial. So our goal is to write is 13s is equal to 2 power k over n factorial. So we want to write this term as a compact form. So in this case, if we observe this term carefully, we see a pattern. If we multiply by 26 factorial here, so 26 factorial also here, if we forcefully multiply 26, so this 26 factorial and 26 factorial are cancelled, rest of are same. 2r minus 1 factorial, 27 minus 2r factorial. Therefore s is equal to r run for 1 to 13, 26 c 2r minus 1 over 26 factorial. Why this term 26c 2r minus 1? If we break this 26c 2r minus 1, we see 26 factorial, 2r minus 1 factorial, and 26 minus 2r minus 1 factorial. That is 26 factorial over 2r minus 1 factorial and 27 minus 2r factorial. That is exactly here. This term is here. So that is we write 26c 2r minus 1, that is equal to 26c 2r minus 1. Now we break this term. Also this 26 factorial is come outside the summation. 26 factorial r run from 1 to 13, 26 c 2r minus 1. Now we break this summation. 1 over 26 factorial, that is r is equal to 1, that is 1, 26c 1, r is equal to 2, that is 3, 26c 3 up to 26c 25. So s is equal to, we got 1 over 26 factorial, 26c1, 26c3 up to 26c25. We know that we write as a note here the ordered term sum of this binomial coefficient. Suppose c1 plus c3 up to ordered term is equal to 2 to the power n minus 1, sub 2 to the power n minus 1. Here also same things, c1 c2 means nc1 plus nc3, that is ncn minus 1, that is that value actually 2 to the power n minus 1. Now we use this value here, so we got 26c1 up to 26c25 is equal to 2 to the power n minus 1. N is 26, 26 minus 1 is equal to 25, 2 to the power 25. Thus s is equal to 1 over 26 factorial, and this summation part is 2 to the power 25. Therefore we write here 2 to the power 25 is equal to 1 over 26. Now we break 26 factorial as 26 into 25 factorial, because n factorial is equal to n into n minus 1 factorial is equal to n into n minus 1 into n minus 2 factorial. In this way we break it, and here 2 to the power 25. Now our actual goal is to find the 13s. S is equal to, we got here, therefore 13s is equal to 13 multiply over 26 into 25 factorial into 2 power 25. So 13 and 26 cancel by 2, so it will be 2 to the power 25 over 2 into 25 factorial. Now our goal is to write 13s is equal to 2 power k over n factorial. Now we got 13s is equal to 2 to the power 25 over 2 into 25 factorial. So that is 2 and 25, it is 2 to the power 24 over 25 factorial. and given that 13s is equal to 2 to the power k over n factorial, so it is equal to 2 to the power k over n factorial. Now we match n and k. We got n is equal to 25 and k is equal to 24, and the question asks what is the value of n plus k. Therefore n plus k is equal to n is 25 plus 24, that it is equal to 49. So this is the answer. And also in the option 8 we will see that the option 2 is 49, so option 2 is correct. In the overall question, in the question given that s is equal to some expression of the factorial, then we see that one pattern follows this sum of this factorial. Then we write the general term tr of this of s, and s can be write as a summation r is equal to 1 to 13 tr. Then we evaluate this and we got this value actually 2 to the power something over some factorial. After that we calculate 13s and we will match is 2 to the power k over n factorial. Then here we find k and n, and we got n plus k is equal to 49. This is the our answer.